This is SpaceTime, Series 28, Episode 76, for broadcast on the 25th of June, 2025. Coming up on SpaceTime, astronomers find the universe's missing matter, more concerns about leaks aboard the International Space Station, and the European Space Agency rolls forward with its new Mars rover. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed earlier observations that suggest the universe's missing normal matter is hidden in hot intergalactic gas filaments. These filaments are a key part of the intricate cosmic web-like structure of the universe, which is made up of strings of galaxies, galaxy clusters and superclusters surrounding vast, near-empty voids. Now, a report in the journal Astronomy and Astrophysics is detailing further support for this hypothesis with the discovery of a huge filament of hot gas 10 times as massive as the Milky Way, bridging 4 huge galaxy clusters. The study's authors made the observations using the European Space Agency's XMM-Newton and JAXA's Suzaku X-ray space telescopes. Over a third of the baryonic so-called normal matter in our local universe, the visible stuff making up stars, planets, galaxies, houses, cars, trees, dogs, cats and people, is missing. While it hasn't been seen, it must be there because it's needed to make science's models of the cosmos work properly. Now, these models suggest that this elusive matter may well exist in long strings of gas or filaments, bridging the densest pockets of space. While astronomers have spotted such filaments before, it's always been tricky to make out their properties. They're typically very faint, making it difficult to isolate their light from that of nearby galaxies and black holes. And that's where this new research comes in. It's one of the first to make this observation successfully, finding and accurately characterizing a single filament of hot gas stretching between 4 clusters of galaxies in the nearby universe. The study's lead author, Konstantinos Migas from the Leiden Observatory in the Netherlands, says that for the first time, the results closely match what astronomers are seeing in their leading models of the cosmos, and that's something that's not happened before. He says it appears the simulations were right all along. Clocking in at over 10 million degrees, this filament of gas connects 4 galaxy clusters, 2 at one end and 2 at the other. All are part of the Shapley supercluster, a collection of more than 8,000 galaxies which form one of the most massive structures in the nearby universe. The filament stretches diagonally away from us through the supercluster for some 23 million light-years. That's the equivalent of traversing the Milky Way end-to-end around 230 times. Mikas and colleagues characterized the filament by combining X-ray observations from XMM-Newton and Suzaku and digging into optical data from several other telescopes. He says the 2 X-ray telescopes were ideal partners for the research. Suzaku mapped the filament's faint X-ray light over a wide region of space, while XMM-Newton pinpointed very precisely contaminating sources of X-rays, namely supermassive black holes lying within the filament. So thanks to XMM-Newton, the authors could identify and remove these cosmic contaminants, so they knew what they were looking at was the gas in the filament and nothing else. As well as revealing a huge and previously unseen thread of matter running through the nearby cosmos, the findings show how some of the densest and most extreme structures in the universe, galaxy clusters, are connected over colossal distances. And so it also sheds light on the very nature of the cosmic web itself. Piecing together an accurate picture of the cosmic web is the domain of ESA's Euclid mission. Launched in 2023, Euclid is exploring the web's structure and history. The mission's also digging deep into the nature of dark matter and dark energy, neither of which have ever been observed, despite accounting for more than 95% of the total mass energy budget of the universe. This is SpaceTime. Still to come, more concerns about leaks aboard the International Space Station, and ESA rolls forward with its new Mars rover. All that and more still to come on SpaceTime. Fresh concerns about leaks aboard the International Space Station have delayed the SpaceX Axiom Spaceflight 4 mission to the orbiting outpost. The 14-day mission aboard a Dragon spacecraft from the Kennedy Space Center in Florida will transport a crew of American, Indian, Polish and Hungarian astronauts. The launch had already been delayed by both bad weather and technical issues with the Falcon 9 booster. Now NASA has put a further hold on the flight so that it can monitor cabin pressure aboard the Russian side of the space station, which has again been venting atmosphere into space. The Russian Federal Space Agency Roscosmos has been dealing with ongoing structural cracks and air leaks within its modules for more than 5 years. In fact, NASA are describing these continuing problems with the Russian segment as a top safety risk. The latest leaks have been narrowed down to the Zvezda module, and Russian cosmonauts have been inspecting the internal bulkheads of the module and looking at possible problems with some of the connecting nodes. They now think they've isolated this latest leak and have sealed it successfully. And NASA says the repairs appear to have worked, with the section now appearing at least to hold pressure. But the delay to the Axiom 4 mission will provide extra time for NASA and Roscosmos to evaluate the situation in more detail and determine whether further repairs are needed. Meanwhile, the 4 Axiom spaceflight astronauts are remaining in quarantine in Florida for the moment, pending a new launch window. Meanwhile, the crew aboard the International Space Station have successfully undertaken a planned orbital correction maneuver. See, over time, as the space station orbits the Earth, atmospheric drag causes it to slowly lose altitude. So every now and then, the space station needs to be boosted back up into a higher orbit. They used to be done by visiting space shuttles. But since the premature demise of the space shuttle program, the job's been taken over by visiting Russian cargo ships. And so this week, mission managers fired up the engines of the Russian Progress 30 cargo ship, which is currently docked to the space station. Progress 30 undertook a 208.4 second burn, enough to push the space station with an impulse of about 0.3 meters per second back up to an orbital altitude of 416.18 kilometers. This is SpaceTime. Still to come, ESA back on track, rolling forward with its new Mars rover. And later in the science report, a new study has shown that conversion therapy is not just psychologically dangerous, but biologically unhealthy. All that and more still to come on SpaceTime. The European Space Agency's ExoMars rover, the Rosalind Franklin, is now back on track and expected to land on the Red Planet in 2028, some 7 years later than originally planned. The Rosalind Franklin was the second part of a two-phase multinational project by ESA and the Russian Federal Space Agency Roscosmos to study the Red Planet. The goals of ExoMars were to search for signs of past Martian life, investigate how the Martian water and geochemical environment of the Red Planet varies, examine atmospheric trace gases and search for their sources, and by doing so, demonstrate the technologies for a future Mars sample return mission. Now, the first part of this program launched the Mars Trace Gas Orbiter to the Red Planet back in 2016. Trace Gas Orbiter deployed the Schiaparelli lander. It was meant to descend down to the planet's surface, landing on the Meridiani Planum. Trace Gas Orbiter proceeded to map the sources of methane and other trace gases present in the Martian atmosphere, which could be evidence of either geological or possibly even biological activity. Trace Gas Orbiter features an array of scientific instruments and also acts as a communications relay satellite, transmitting surface operations back to Earth. As for the Schiaparelli lander, well, it was designed to test new key technologies to safely deliver the subsequent Rosalind Franklin rover mission down to the Martian surface. However, while the orbiter is still successfully working, studying the Red Planet from orbit, Schiaparelli failed during its descent, crashing into the surface. Now, the second part of the ExoMars program was planned to launch in July 2020, when the Russian Kazachok, or Little Cossack lander, was meant to deliver the Rosalind Franklin rover to the Martian surface. However, ongoing problems with the development of the Russian lander repeatedly delayed the mission. Then in March 2022, the European Space Agency suspended the mission altogether, following Moscow's invasion of Ukraine. Finally, in April 2024, the mission was revived after it received new funding from ESA to restart the development and delivery of the Rosalind Franklin rover, and with NASA now agreeing to provide launch services. This report from ESA TV.
The ExoMars missions began in 2016 with the successful launch and deployment of the Trace Gas Orbiter.
This first ExoMars spacecraft is now nicely orbiting around Mars. It's fulfilling very well its scientific mission, And it has proven as well its capability to relay data from Mars assets to the Earth, and we use for that the American rovers.
This proven capability will be needed to communicate with Europe's first Mars rover, Rosalind Franklin. A landing site in an area called Oxia Planum has been recommended for this joint Eastern mission, which has 4 elements.
We have a carrier module to push the spacecraft to Mars. We have a descent module to bring the landing assets, the rover for the European and the landing platform down to Mars. And we have the rover, which is the main interest of the Europeans into the mission. This rover carries 9 payload instruments that will fulfill basically the main mission to discover traces of life on the planet.
The rover, which was built at Airbus UK, is now undergoing final tests in Toulouse, France.
And in that report from ESA TV, we heard from ESA ExoMars team leader Francisca Spotto. Now, with its new 2028 launch deadline, ESA is once again working to produce a workable Rosalind Franklin rover, testing it under a range of different Martian conditions and terrains. The project's been putting a full-size model of the rover through its paces in a series of tests designed to fine-tune how the rover will move from its landing platform down to the Martian surface, and then how it will explore the Martian world beyond. See, the thing is, rovers on Mars have previously been caught in sand, and turning the wheels simply dug them in deeper, just like a car stuck in mud or snow. To avoid this, the engineers behind the Rosalind Franklin rover have developed a unique locomotion mode known as wheel walking.
This is a dedicated facility where it simulates all what we expect to see and we want to test in terms of performances on Mars. The arrangement is a setup we have to perform egress tests. Actually, what we're testing in this period is different configurations of slope and orientations of the lander and the rover.
In reality, what will happen is that the rover will land encapsulated in the platform. Then it will unfold the wheels and the ramps will be deployed. This is a very delicate and potentially dangerous operation.
We want to account for any adverse situation. For example, landing on the foot of a small hill, which have our lander tilted. Or landing when our ramps open, we have an obstacle on one of them, or one of the other ramp lands on an obstacle, so you have to egress in a tilted configuration.
Now the test platform is tilted 5 degrees. We are simulating what the rover might encounter when it lands on Mars. We are increasing the level of difficulty of this test. Before, we went for 5 degrees. Now we are moving up to 15 degrees.
The rover has to overcome actually obstacles which have a height of at least 250 millimeters. There are pyramidals, round or square ones, and we will test to overcome one or several in different inclinations.
With our deployment actuators being strong enough, we can implement an additional locomotion mode, which we call wheel walking, which articulates a motion, and this motion gives very good traction capability in very soft soils and in very high slopes.
Eventually we will be able to go to places to find interesting elements on the surface of Mars and basically achieving the intended operations and the return in terms of science. We are on track for Mars. We plan to complete this test basically as planned with some minor glitches here and there, then continue with further more elaborated tests.
Many other tests are taking place across Europe to get the rover ready for Mars. While the flight model takes shape, science instruments are carefully installed and the software runs all possible scenarios to guarantee a good performance on the red planet.
And in that report from ESA TV, we heard from ESA ExoMars rover mobility systems engineer Pantelis Polakis, ESA spokesperson Egida Vincente, RUAG locomotion verification systems manager Boris Holter, and Airbus locomotion verification model architect Jesus Quince Garcia. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that conversion therapy, that's where kids are encouraged, often forced, to appear to change their true sexual orientation and gender identity, is not just psychologically damaging, which has been proved in previous studies, but is also biologically unhealthy and linked to higher blood pressure and inflammation. A report in the Journal of the American Medical Association found that this link was still strong, even when the researchers accounted for a range of outside factors, such as demographics, health behaviours, and HIV status. They found that most of the 72 study participants who had been exposed to conversion therapy said the experience affected them very negatively. And so researchers suspect that the blood pressure increase has something to do with the release of the stress hormone cortisol. Archaeologists from the Australian Museum have unearthed 693 First Nations stone artefacts, some of which date back to the last ice age. The artefacts were found in an ancient Blue Mountains cave known as the Dargon Shelter. The findings, reported in the journal Nature Human Behaviour, are new evidence providing definitive proof of the repeated occupation of this once frozen high-altitude landscape. Engineers say a new filter for infrared light could see scanning and screening technology tumble in price and size. A report in the journal Laser and Photonics Reviews says the new heat-tunable filters are built on nanotechnology and promise handheld robust equipment which can replace the current generation of desktop infrared spectroscopy setups that are bulky, heavy, and can cost from $10,000 to more than $100,000. Because the new instruments will be built on silicon chips, the manufacturing can be scaled down with the potential to push costs down to below $1 per filter. Apple have finally rolled out some long-awaited new features for its iOS 26 update, which will finally offer its users what's already available in other cell phones. With the details, we're joined by technology editor Alex Zaharov-Reut from TechAdvice.life.
One of the features on iOS 26 is going to be call screening and call holding. And that's something that Google Pixel users have had for years, but it's going to become standard. This is something that's going to be a real quality of life improvement. I mean, normally when you get an updated phone, you normally are not talking about the phone call part of the equation. It's about how good the camera is and how much memory it's got and what are the other new features for AI. But in this case, it's using some AI features to deliver call holding and call screening. So if you get a phone call and it's from a number that is new to you or you haven't saved it into your contacts, the iPhone will answer the call for you and it will ask the person, well, what are you calling about? What is it you'd like to get this person's attention for? And so that person then has to explain what it is they want to tell you. And then after that, the phone will ring. You'll be told or you'll be seeing on the screen what it is they want to talk to you about. And then you can talk to them. And obviously, if it is some sort of salesperson trying to get you onto a new electricity bill, well, you can just ignore it. Then the other big problem of the modern age is having to call your bank or an airline or some utility and then being stuck on hold for half an hour, however long it takes. And what the system will do is it will go on hold for you. It will allow you to stop listening to the hold music. It will then answer the call when the person comes on the line to take your call and say, okay, this is the iPhone system. I'm just going to contact the person calling you right now. Hang on, please don't hang up. And then the phone will ring and suddenly you're talking to the customer service agent. And that's going to free up a lot of time. You can do other things. You can put your phone down, not have to be listening to this repetitive, boring hold music about how your call is important to us. And again, these are things that Google Pixel owners actually have enjoyed for some time. And I've been wondering when this would come for iPhones. And many iPhone users will be able to enjoy this from September later this year when they launch the final versions of the new system.
The other big news has been the latest with Telstra and its satellite communication system. What's happened there?
Yeah, so they launched it to be compatible initially with the Galaxy S25 range of Samsung smartphones. And then the weekend after that launch, they announced a whole series of iPhones were also now compatible. Now, the important thing is, and people have said to me, does this mean I can send it via satellite when I'm in a room of the house or somewhere, on my property that doesn't get service? And it's like, no, it's not designed to be used in areas where you should have mobile reception. For that, you can use Wi-Fi calling or you can call over WhatsApp or FaceTime, some sort of other system. But this is for when you are specifically outside of Telstra's mobile range. The phone will then say Telstra SpaceX, and you can send a message to anybody, including emojis. And Telstra announced that within the first 10 days of that feature being switched on, over 1 million text messages were sent and received. But the fact is, it works. And we should see Australia's other two big carriers announce similar capabilities at some point, and we already have this happening in the US. So this is shrinking the tyranny of distance. And later this year, you'll be able to do phone calls and data as well. So yeah, ubiquitous communications is a reality that's getting ever closer and nearer.
So for now, this is just SMS.
Just SMS for now, just text messages. You can't, as far as I'm aware, send any images because that would require data. And also, it's not instant. You've got to hold your phone up and make sure the satellites are overhead. It's a bit like the emergency SOS messages that were sent before through iPhones, but only to emergency services people. Now you can send a message to anybody, and that can be very handy if you're broken down and there's no cars driving by and you need to contact someone to say, hey, get the NRMA or the equivalent car assistance, roadside assistance people. The auto clubs, yeah, absolutely.
That's Alex Zaharov-Reut from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.